right, let's go ahead and do the second part of this video. This is for the next day. Yesterday, we already covered the first half of this. If you haven't done the one from yesterday, make sure you see that one first. If you haven't done that one lesson from last week where we graphed the sine and cosine, make sure you see that before any of these, or else this will all be confusing. I have the steps down, same exact steps, but now we're going to be combining both of them, so it's going to be a horizontal and a vertical shift. So go step by step, find your maximum and minimum point, your period, divide that into 4 parts. If there's a horizontal shift, you're going to add or subtract by the number of radians that they have. And then if you have plus k or minus k, you're going to be shifting 1 unit up or down. Example 3, we're going to go ahead and solve for this. First thing we're going to do, you find your amplitude. So I'm going to use a different color for this. You find your amplitude, and your amplitude is the number in front of sine. It's always at A, and that will be 1. Oops, that's terrible. 1. Period. You do 2b, or 2 radians divided by your b. b is a number in front of sine. In this case, we don't have one, so it's over 1. You can divide your radians into 4 parts. So 1/4 divided by 2 radians, 2, or 1/2 divided by 2 radians, 3/4, and 4/4, or just 1. So 1/4 times 2, you get radians over 2. 1/2 of 2 radians, just radians, 1/2 of 2. 3/4 times 2, you end up with 3 radians over 2. And then 1 times 2 is 2, which is 2 radians. So those are your normal steps. That's gonna be your wave. It's gonna show how your wave is gonna look like. Step 4, identify any shifts, left or right, up or down. Here we have parentheses. In between we're adding the radians here. What that means, always think of opposite signs. We are subtracting radians from each of our wave from our period. But on top of that, so we're shifting it to the left and we're moving 2 units. That plus 2 means we're moving it 2 units upward. So again, we always start at 0. I don't have the 0 there, but I'm going to put it there now just to show you. You always have that starting point, which is your origin. So here we're shifting radian units to the left, so that means we are subtracting radian units to each one. So when you do that, 0 minus radians, negative radians. Radians over 2 minus radians, or 1/2 minus 1. I just want to make sure I don't mess up here. I have negative radians over 2. Radians minus radians is 0. 3 over 2 minus 1. I end up with radians over 2. And then 2 radians minus radians. 2 minus 1 is just 1, and you have to include the radians there. So that means your new set of points are these here because of your shift. So now we identify what type of graph. It's a sine graph. That means you start with 0 to your maximum, 0 to your minimum. I'm going to go ahead and put that on the side here. So 0 up, 0 down, and back to 0. So you're going 0 up, 0 down, 0 up, 0 down, and that can be never ending. Now we're going to go ahead and graph each one of these. Keep in mind when you're graphing them, I'm not going to graph the original one because it's not going to matter anymore. We have so much of a shift to it, so it's not going to really matter. So here, we have to keep in mind we have to count 2 units up from every point we're going to graph. So the first point is negative radians. That's our starting point. So here, typically we go at the origin, so the x-axis, we're going to go right here. But keep in mind we have to move 2 units up for every point up on the graph. So 1, 2, 2 units up is this right there. Next one is negative radians over 2, which is here. Normally we would go up to our maximum. Our maximum would be just 1. So from this point here, we have to move 2 units upward, which is that point right there. Next one is 0, so that's right here at the origin. We go at the origin there, but make sure you're moving 2 units upward, so that's going to be right there. Radians over 2, we have radians over 2 here. We are going to go down and go down to your minimum point, which is 1. Which is radians over 2, which is 1 here. But keep in mind, you're always moving 2 units from that original point. Before you graph it, count 2 units upward. And then radians, you're back at the origin, so that means you stay there, but keep in mind you're counting 2 units. So now you have a graph that looks like this. So if you want to keep on going, it's going to make it like that. So it's going to look like that. Normally, the sine graph looks like that. and you can see the shift of it. It moved to the left, and it got wider just because of the amplitude. We're counting 2 units upwards, so it did shift. It shifted to the left, and therefore that's why you have your first graph. Next one here, we have a combination of both. So they're combining a lot of it. They're adding the amplitude. They're adding different periods to it. They're just making it a more complex graph. So what we do, we go ahead and go step by step. You always go step by step for each one of these problems. First one, find your amplitude. In this case, now you have an amplitude, 3. So that means your max is 3, your minimum is 3. It's not 1 anymore. Your period is 2 radians divided by the number in front of x. In this case here, we have a 2 in front of x. So when you do 2 radians divided by 2, you're left with radians. So that means you're going to be dividing all your 4 parts from radians. Radians is 180 degrees. So when you do that, and just to make sure I don't have it messed up, 1/4 times 1, which is just radians over 4. 1/2 of radians is radians over 2. 3/4 times 1 is 3/4. So just add the radians next to it. 1 times radians is just 1. So then we have that. The fourth thing, identify any shifts. So here we have 2 things going on. We have 2 different types of shift, the horizontal and the vertical one. Horizontal, so we have to see if it's shifting left or right. In this case here, it's x minus radians. Always look at the parentheses where the x is. That's your shift right there. So it's minus radians, so that means you're going to be adding radians to each one. This is where you're going to include your 0, because that's your starting point. So you're going to be adding radians to each one of these because of the phase shift. And then on top of that, they have a shift of 1 unit upward. So from on top of that, we have to keep in mind we have to add 1 more unit up every time we graph it. Now, I have my pattern here. I changed it a little bit because now my amplitude is different. So instead of 0 up, 0 down, it's now at 3. So my amplitude, I start at 3. That's going to be my maximum point. My minimum point is going to be -3. So then instead of putting up 0, down 0, I put 3, 0, -3, back to 0. That just helps me to graph a lot better. Now, if we were to add these, we get radians. 1/4 plus 1, we get 5 radians over 4. 1/2 plus 1 is 3 radians over 2. So it's 3 over 2, add the radians. 3/4 plus 1 is 7 radians over 4. And then radians plus radians is 2 radians. So these will all be your new shift. Now, to not make me mess up, because it can get confusing if you don't go step by step, I follow the pattern here. So I go my maximum, which is 3, back down to 0, back down to -3, back down to 0, back up to 3. And that's how I would graph it. And on top of that, I have to keep in mind I have to count 1 unit upward. So now, let's go ahead and graph. I have my increments here. I put in increments of 45 degrees. So I didn't put it because I don't have that much room. So this is 45, 90, and etc. This is 180, and etc. This is all the way into 2 radians here. If you notice, your period is from radians to 2 radians. So it's half of a normal period. So now let's go ahead and graph it. So we start at radians. So our radians is over here. We start at our maximum point. So 3 is right here. But on top of that, you have to count 1 unit upward. So your new unit is that one. 5 radians over 4, that's actually between here. I didn't put it down here. So 5 radians over 4. If you multiply it out, I believe you get 225. So you have 5 radians over 4. And you're gonna start at your 0 here, but remember you have to count 1 unit upward. So that's gonna be right here. 3 radians over 2, that's at -3. So -3 is down here, but we have to count 1 unit upward. So we'll put arrows, just 1 unit upward. 7 radians over 4, I think that was 315, somewhere around there. So that's gonna be right here. And that's back at my 0, but then I have to count 1 unit upward. So that's gonna be right here. And then 2 radians, I have back at my maximum point, which is 3, but I have to count upward at 4. So my graph is going to look like this. And that's one shift, one phase shift. A one wave, And to just keep on going, I'm just going to follow it. So I have here radians. So this is going to be here. It's going to be here. It's going to be here. It's going to be here. And it's going to keep on going and going. And it's just going to be repeating. So as soon as you have your pattern, it's just going to be the same thing. It's going to look all over it. It's going to be intersecting there. When my wave is from radians to 2 radians there, I just include the rest of it to have that much of a wave. Now the last one, we have the combinations of, again, all of them. Now, grab my green one, find your amplitude. So your amplitude here is -2. So instead of starting, whenever you have a negative in front of your graph, instead of starting on the top, you're starting on the bottom. So for sine, instead of going 0 up, 0 down, you're gonna go 0 down, 0 up. Cosine, well, this is sine. So you're gonna go 0 down, 0 up. So it's going to change it. It's going to be an inverse graph. So my amplitude is -2. My period is 2 radians divided by your b. b is the number in front of x. That is 1/2. That means you have a complex fraction. Multiply the top and the bottom by its reciprocal. That means you're going to get a period of 4 radians. That's double of what this one was. Normally it's from 0 to 2 radians. This one was half of that. This one's going to be double of the 2 radians. It's going to be 360 times 2. It's going to be a lot bigger than it usually is. Now, let's go ahead and divide that into 4 parts. 1/4 of 4 is radians. Half of 4 is 2 radians. 3/4 of 4 is 3 radians. And then 1 of 4, it's 4 over 4, 4 radians. It's just 4 radians there. So I divided it. It divided evenly. If you notice, all of these here have a pattern, so you don't have to continue this. I just wanted to show you the 4 parts to show you there's a pattern going along. If you just divide it by 4, you'll notice what the increments are. If you convert this all to degrees, you'll notice there's increments of 45, of 60, of 90, of 180, or of 360. Those are the main ones. You'll see a lot more of the 360, or no, of the 180, the 45, and then this one's just the 180. Now we go ahead and we divide it into 4 parts. Now we talk about shift. When we talk about the shift, we look at this here, x plus radians. That means we're going to be subtracting radians from each one of the 4 parts. So I started at 0. I'm not going to use that one. I started at 0. 0, I'm going to subtract radians from it. I'm going to subtract this radians from there, subtract radians from there, from every part. And then before I solve it out, I also have to move 1 unit downward. So when I graph it, I have to count 1 unit downward. Now, go ahead and subtract it. 0 minus radians, negative radians. Radians minus radians, I get 0. 2 minus 1, 1 radians. 3 minus 1, 2 radians. 4 minus 1, 3 radians. And these are all your 5 parts to a wave. So there's technically 5. We don't say the first one because it's always at the origin. But now because of this phase shift, it makes it a little bit more complicated. Now, let's go ahead and graph the pattern. So sine usually is 0 up, 0 down. It's now going to change because of the negative. It's going to be 0 down, 0 up. Also, your amplitude is not at 1 anymore. It's at -2. So that means you work 0 down. So it's -2, 0 up at 2. So 0, -2, 0, 2. Well, I missed one. Press the 0 here. 0, -2, back to 0, up at 2, back to 0 there. So that's going to help me to graph it. Keep in mind, you have to graph the number of units that's shifting, which is 1 unit downward. Now, I'm going to put this down. So at my starting, which is negative radians, I'm starting at the 0 mark here, so that's x equals 0. But now I have to count 1 unit downward. Yep, like this. That's going to be right there. Now, at 0, so that's at the origin, we're going to go to our minimum point, which is -2. But now we have to count 1 unit downward, and this is my new point here. At radians, I'm back at the origin line, so back at the 0 here, but now I have to count 1 unit downward here, this is -1. And then at 2 radians, I go back at my minimum or my maximum point, which is up here. But remember, we have to count 1 unit downward. So then it will be over here. And then at 3, we have it back to 0. It's back to 0 here. We count 1 unit downward, and we have this here. So when I graph this, I get that graph right there. And it's a lot bigger. Normally, a sine graph looks like, normally a sine graph looks like that. But if you notice, it got a lot wider and it's a lot larger of a period because a period is from 4 radians, it's from negative radians to 3 radians, which is a total of 4 radians altogether. So the wave is from here to here. Very large wave. For your homework, make sure you have everything labeled. Make sure you have your steps there so I can see it. Do not just give me a graph. That tells me you did no work to it. You didn't do anything to get to this part here. Make sure you have your work labeled. So if you need any more help, make sure to let me know down here at my emails. I'll be there waiting. Sometimes I won't answer. I'm a little busy, but I will get to you as soon as I can. Bye-bye.